Hello students, today we will be going over 2.1 discrete versus continuous relations and notations. Now, I'm going to just go over this vocabulary really quick and then we'll be moving on. Our objective, I can use interval and roster notation and identify discrete and continuous relations. Set, a collection of distinct objects, and I'll let you read that on. Roster notation is basically those curly brackets. Like this. Okay. And if you have problems with that, just do like a forward and backwards E like that. But try and get it like that if you can. Intersection is the set containing elements included in both sets. So here you have set A and B. If I take the intersection, and again, that notation is like an upside down U, so it looks a little bit like an N. So it's what's in common in both. Think of that N, common in both, and that would be just the 5 right there. Union is like unite. Let's unite everyone together. So the union of set A and B is just all of them, 3, 4, 5, 6, 7, and there you have that. So example number 1, give roster notation for each set. Set L over here. We'll just list the numbers from least to greatest. Set H is over here, least to greatest. The intersection between the two is where they cross right here. It's just 31. And then union of both of them, you just list all of them starting at the smallest number, 7, 8, 9, and so forth there. Okay. All right, now we're going to go ahead and go to the other packet, and we'll talk about discrete and continuous a little bit later. So here we're moving on to page 23. Okay. Hopefully you can see that okay. All right. Now, let's look on page 23, number 1. And I think that will get rid of that one shiny spot. Does that get rid of the other one? Nope. Don't know what it's reflecting off of, so we'll just continue. Okay, so we're just going to list all of those in set A right there. And we're going to start with the smallest number, and that is 2. Okay, and then the next one is 5, 6, and again, we're listing them in roster notation, and roster notation is the curly brackets, which it says right there. So we go 2, 5, 6, 10, 43, and 78. Commas between each one, curly brackets at the end. Set B in curly bracket notation is we start with 1, 2, 6, 11, 24, 41, 61, and 74. Okay, now if I was going to go A intersection B, that would actually be what's in common in both. Oh, whoops, I didn't put B over here, but B is supposed to be over here somewhere. So A intersection B would just be 2 and 6. And if I was going to go A union B, I would list all the numbers there. And I'm not going to take the time to do that because we have a lot to go over in this video. Okay, next on the same page, 23, we're going to look at number 4. Right over here, again, roster notation is the brackets. Interval notation is like this. Normally, you use roster notation for discrete functions, and discrete functions are basically a set of points, and continuous functions are some kind of curve or line. Okay, so over here, we're doing roster notation, and we have a set of points here on a number line. So if I always start with the lowest number, -5, -3, -2, 0, 1, 2, 4, and 5. Okay, so there's another roster notation. Now we're going to do one in interval notation. We're going to jump to number 11, and we start with the lowest number first. So the lowest number on this number line is -infinity. Now with -infinity, we actually never put the brackets this way. For infinities, we always use these, okay? Because you can never reach infinity, and this includes the number. So we can't include infinity because it goes on forever. And it goes up to 4. Now, if it's going to include 4, which this one does, I'm going to put the bracket. So the bracket includes the point. And we're going to unite that or union that with 7, not included, and then we go up to positive infinity. And again, we never can quite get there, so infinity is always in parentheses, not brackets. 4 is included, so it has brackets. Now we go on to number 13, and we start with -1 as the smallest one. Can you see that okay? So we go -1, and that goes up to 2, and we don't include 2, so that's a parenthesis. And then we unite that with the point. In between this is also shaded, so we include 2, 3, but not the endpoints because they have open dots there, so they're not included. And we're going to unite that also with 3, not included, because it's open dot, all the way to infinity, parenthesis there. Okay? All right. And I guess I should include on the interval notation up there, probably intersection. So make sure you know what those mean. Look over the vocabulary in the pink packet if you need to. Okay? So again, this is in the white packet. Let's go on to the next one. Okay? So just as a reminder, discrete is a set of points. And continuous is a line or curve or circle, etc. As long as there's some kind of connection, it's continuous. If they're just points on a graph, then it's discrete. So discrete is going to be a roster, which means curly brackets like this. And curve means it's going to be interval, which means you're going to have something like this. Again, interval notation includes all of that. Usually you don't use intersections that much in intervals. Okay, so here, what is it, discrete or continuous? Well, let's see. It's a set of points, so I'm going to say it's discrete. And discrete usually goes with a roster. So we put that one for 19 is discrete and roster. Okay. Okay, now for number 20. Right here, this is what's called a mapping. And basically, it's saying 6 goes with 3, 7 goes with -4, 8 goes with 1, and 6 also goes with 5. So we have just a set of points. So it's going to be the same thing, discrete and roster. 21. Okay, that's a line. It's continuous. So it's going to say, we're going to name that continuous, and it's interval notation is what you would use, okay? All right, students, you can get the rest of this. You rock. And hopefully you can see that okay.